dive into deep learning or D2L. So I will introduce that a little bit later during my presentation, but welcome everyone for joining us this morning.
Thank you, Rachel.
Thank
and
you.
Finally, I have Miro Inov, who is a principal solutions architect and a long time collaborator with us for the last 4 years since I've been at Amazon. Miro, you want to introduce yourself?
Hey everyone. Yeah, this is Miro. Thanks for the intro, Wending. Looking forward to a great workshop and helping folks out who have questions along the way. My work focuses on data science and collaborations with partners like Amazon. So feel free to reach out if you have any GPU related issues or if you have any questions. Thanks.
Yeah, and we'll be sharing these slides. In fact, it's on the GitHub already. So our emails are clearly written here. So feel free to contact us for any reasons. So that includes if you're looking for a job, we'll be very happy to help. And of course, I want to introduce our student helper, Ayush. Thank you for helping with this session. Very much appreciated. Liam Morrison is another helper, and he is a solutions architect, principal solutions architect at AWS, and he is very knowledgeable about AWS in general. So if you have any questions during the session, please do feel free to ask any one of us if you shall have any run into issues or if just any questions about AWS at all. So we'll be happy to help. Our emails again are presented here, so feel free to reach out to us. So first of all, I'd like to present you with the objectives. So we want you to be able to learn as much as you can during the session. And the key here is to really, kind of have a friendly community learning atmosphere so that everyone should be able to help each other when you are actually going through the labs. So do feel free to ask any questions at all. There's no such a thing as a stupid question. So please do ask. And we, either if you feel like you don't want to ask publicly, ask one of us privately. We'll be very happy to help as well. I think the key thing is to help you understand AI/ML industry trend. There's a lot happening in both academia as well as industry. So there are some of the things that we're doing at Amazon I'm happy to share, and how we do certain things and try to solve some of the challenges. And then we'll go over our machine learning tools and services offerings at AWS. Normally, this is like a 2-day or 3-day class. So we're trying to compress down to about 20 minutes to about an hour. So we'll be skipping a lot of things, but again, feel free to ask me if you have any questions about specifics of any of the services. Rachel will be doing a deep dive into BERT. And I know many of you are getting lots of exposures of BERT, but it's always a great opportunity to get another perspective of it. And also, it's essentially another epoch, right? Another epoch for you to be able to understand some of the concepts that you may have missed in the first few times you've learned it. And then, of course, the main reason we're holding this workshop is to give you hands-on experience on AWS. And this is something that normally not everyone has the opportunity to do so. Especially for this lab, we were able to get 4 GPUs per participant for you, P3. These are the P3 GPUs, Volta 100 GPUs that would allow you to be able to train at scale and efficiently. So that's not something that you would be able to normally get easily. So we want to provide that to you as an opportunity to learn, just to get a feel of how it would work to train with multiple GPUs. And in the process, you'll learn about Elastic Container Services, or ECS. It's a way of doing container services. In many ways, I would consider it as a much simpler than EKS or Kubernetes or any of these more generic but more sophisticated way of doing container orchestration. And finally, we will be showing you how to use a tool built by Amazon Web Services, and it's getting more popular. So in fact, one of my goals is to have internal adoptions of SageMaker, and that is becoming the de facto tool for many of our internal teams when it comes to building, training, and also deploying machine learning services at scale. So for example, there's something called a multi-model server, which will allow you to host 400 or 500 models all at once, and it would be able to switch them in and out based on the caching that is implemented. So that's our objective. So the agenda is, I would say it's loose, relatively, I would say loose at this point. So it'll probably be off by maybe a few minutes here and there, but that shouldn't be an issue because we have about 30 minutes at the end. So the objective again is to make sure that everyone learns as much as you can. Also get the opportunity to hands-on and try AWS given the 3 hours that we have. So again, I will do the overview, and then Rachel will be doing the BERT transformer explanation, and they will do the lab. There are 2 parts to it. The training process does take a little bit of time, and it also gives you a feel of what it is like to be training like a data scientist. So as a former developer, so my excuse for going to take a break is compiling time. So the excuse for data scientists, I finally figured that out, is I'm training the model, right? So, then we will also have Miro be showing you some of the, frameworks that NVIDIA is building, something called NeMo. So the idea is that you have an end-to-end model. So be able to chain all the deep learning models together for you to be efficiently running through that pipeline or workflow and produce a very efficient way of deploying deep learning models in combination. Okay, so first of all, I would like to kind of just get an overview or a review of where we have been and where we are actually going. So with this chart, I don't think anyone is, I think most of you have heard of GPT-3 by now, but we started with ResNet. This is only 5-10 years ago. So I don't know what the next model is going to look like. It'll be a 10 trillion parameter models or something even bigger. But everyone is intrigued and fascinated by something like GPT-3. So there's a few trends I want to point out. One is that to build something like GPT-3, it will cost you about $5 million or so. And if you kind of work backwards from there, if you were to train a BERT model today on AWS, it's probably going to cost you about, I don't know, about $10,000 or so if you use efficient spot instances. So these models are becoming, really, really expensive to build. So Miro will actually go into the efficiencies of transfer learning, which is also what the lab is all about, and how you can, essentially use transfer learning to make these models work for you and take advantage of a lot of the pre-trained models that exist today. But again, deep learning and machine learning is getting more complex and more difficult to build state-of-the-art models. But at the same time, the models that have been built are becoming easier for everyone else to be able to utilize in the industry. So in terms of machine learning use cases, the most, I think 3 years ago, we were mostly seeing a lot of image analysis, video analysis applications. That was, the key workload that we were seeing, even from within Amazon. So Amazon Go is one of our AWS customers. So they use a lot of our services, including the machine vision, also MXNet. And in the last year or so, things have really changed. Natural language processing is becoming the dominant workload. So a lot of our customers are asking about how do you optimize things like BERT? How do you build it in such a way that you can inference it with thousands of hosts. How do we utilize these natural language models for other applications? So it's becoming probably the dominant model just because data is readily available, right? And also the second trend is what we're seeing is that there's a lot more vertical services that are starting to take advantage of machine learning and deep learning. So especially in financial services, healthcare. I think healthcare is one of our largest areas of where a lot of customers are asking a lot of demand. It's probably very much coincident because of the fact that we have COVID happening right now. Recommendation systems, again, people were traditionally using recommendation systems are building bigger models, and people who weren't using recommendation systems, essentially, popping up top 10 of the customer liked on their website, are starting to use these recommendation systems. And of course, there's autonomous vehicles, given that perception, image perception, LiDAR, and all of the hardware is getting better. These models are also getting more sophisticated. More surprisingly, we're seeing before COVID, we were seeing a huge spike in terms of travel and hospitality type of use cases in terms of really recommending the right user experience for their customers. And of course, there's energy and manufacturing, which are already on their way in terms of building a lot of IoT-like devices for machine learning. So for those of you who are not familiar with AWS machine learning stack, so we probably started about, I don't know, 5 years ago, 4 years ago, probably, yeah. 4 years ago is when our machine learning team started at AWS. So we've come a long, long way. I would say the first thing is we started with, I think, Amazon recognition. So today, there's so many different customers and services using recognition for video analysis, for broadcasting, I mean, these scenarios are becoming very real. And we also have things like Amazon Polly, which is used by Alexa team. So Alexa team spends a lot of money with us on Amazon Polly when it comes to synthesizing the human voices. And there's Transcribe. Transcribe is a relatively new service, and it does medical transcription. So if you're in a doctor's office, you can transcribe a conversation between a patient as well as the doctors and nurses. So these conversations are relatively difficult to do. Comprehend is part of our natural language processing system. So we also have translation as part of it. Kendra is a search application. The Kendra is essentially used more and more by enterprise. So we're using them internally for index a lot of documents, essentially using natural language as well as search as a combination to be able to provide much more accurate content provision. So there we also have chatbot among other different services. So if you can think of one, there's probably a managed services already. So these are catering to people who are not necessarily data scientists. They just want to use an API. So developers tend to use these services quite a bit. And there's also another trend I'm spotting, which is these managed services are actually converging with the second layer, which is things like SageMaker, where you're building your own model. So there is actually some training capability that custom training capability that's allowed in things like Personalize, which is a recommendation engine. Forecast is a forecasting engine. CodeGuru actually kind of replaces developer review process and will review your code and find a lot of errors and problems for you. So on the second layer, we have the Amazon SageMaker as a machine learning service. So the idea is that we have an end-to-end way for you to prepare, process your data set, give you an opportunity to look for algorithms that are existing in the machine learning marketplace, and allow you to build in the Jupyter Notebook environment and then run experiments or training process, look at debugger, be able to do hyperparameter tuning, and then there's AutoML, among other things, being built into it. And more importantly, the model serving is probably the most used feature. And what's really interesting about model serving is that, you know, I work with our internal teams. So I would say, you know, almost 60–70% of all of the resources being used on SageMaker is actually model serving. So being able to build a efficient model serving mechanism that auto scales, that supports multi-model, those are fairly difficult to do. So we also provide you with model monitoring. So in fact, if there is any type of drift that's happening. So at the very bottom layer, which is what a lot of folks here would actually be using. So that is that all you're familiar with. That is the frameworks, the different frameworks that is offered, as well as our GPU offering. So later in a later slide, I'll explain some of the GPU capabilities that we have, as well as one of the custom chip that we built called Inferentia. Yeah, so here's the slide that talks about our EC2 offerings. The P3 is and also P3DN. So P3DN is the double the memory instance type. It's 32 GB of RAM and also has a much faster networking built in. So G4 is the NVIDIA T4 type. And that is generally really good for inference workload. And we also use it for training. So I've used it for training, and it typically can do very well if you just use Tensor Core. So if you use mixed precision training, it can speed up about, I don't know, 2x or so. And if you used, let's say, if you used the inference. So for example, you know, some of our video services, largest videos, internal customers are able to get 4x speed up if you use Tensor Core only. So on the inference side, we have T4. We also have our own custom inference chip. So since 90% of the workloads are actually inference workloads, so we've decided to build our custom chip. So if you're interested in trying out the Inferentia accelerator, definitely let me know. We'll be happy to point you to the right folks to help you with. So the next step is for me to make a brief introduction of SageMaker, and you're going to be having your hands-on experience with it. So I'm not going to go into too much details of each. The original idea or positioning of SageMaker was actually for developers. So the idea is that data scientists already know how to do a lot of things, but turns out that it's we're seeing a lot of data scientists and developers working together in an environment. So just having a common environment which both job functions can work together turned out to be super efficient and really very compelling to our customers. So it comes with the pre-built notebook like any system would have. So that's Jupyter. And then it has one-click training. So the training itself, one thing really, really nice about it is it's only build as the training is running, and that I can't emphasize more on how important that is. So I think I know lots of people have been keeping their GPU instances running and forgetting about it, and that's going to start costing you a lot of money. So I think it costs like $2,000 or so a month if you just forgot about your instances. I know someone who left 16 GPUs running and just forgot about it for 3 months. So that's going to start costing you a lot of money. So that's why this is actually really important. If you can, definitely try to use SageMaker, because using the training API, it will start billing you at the very beginning, and as soon as the training stops, your billing also stops. Okay, optimization, there's HPO among other things that we'll look at in the later slides. But again, I think the key here is to be able to deploy this very easily with one click. So here's a quick look at how visual of how an engineer would normally use the system. So you'll probably have someone who is an engineer or a data scientist who's using Jupyter Lab or the notebook services. We also have the latest one, which is called SageMaker Studio. And then you'll be training the model on our training instances. The training instances allows you to have multiple nodes as well, using Horvault, as well as parameter servers. And then what you would also do is to create an endpoint, right? So once you've trained your model, you have an endpoint. And you configure that, and then you'll deploy the model into production and run live data against the productionized model. And it also allows you to be able to do A/B testing as needed. So one of the things I wanted to mention here is something called we have a labeling service, and this particular labeling service allows you to be able to label simple data set in terms of using the bounding boxes and image classification, and also semantic segmentation, but also point cloud. So those point cloud models can actually take a long time to be able to build. And one of the point cloud models that I know someone was building, it took them 6 hours to just annotate one point cloud, and that can be fairly sophisticated. And we support custom UX for you to be able to do the classification and also all the different type of labeling. And we also support active learning. So if the machine actually saw enough labeling and it's able to distinguish things on its own, humans only will get the ones that the machines are not so sure about. And we also provide you the opportunity of using this ground truth allows you to be able to use a public on-demand workforce that originates from the Mechanical Turk, using your own team to be able to do the tagging, and also a vendor. So there is actually quite a few. There's a huge industry behind this, where there's a lot of vendors that would provide that service of labeling things for you. And some of these workers are extremely skilled to be able to do things. And for example, I wouldn't be able to tell different type of cars, but there are specialized people that are specialized on labeling, on specialized data sets. So this is an important part of an enterprise offering that we have. So for training, there are multiple ways you can do this. So at the end of the day, it's whatever is the most convenient for you. So you can use the built-in algorithm. You can bring your own containers. So this is all very flexible. At the end of the day, everything is built upon something called ECS, which is a container service. So you are given the flexibility to be able to do all of the above. So if you're able to use any of these built-in algorithms, the container is already built for you. And also we have a very simple way of doing distributed training and deployments. So definitely try to use one of the built-in algorithms like XGBoost and also image classification, object detection. So these are all based on ResNet. So essentially wraps everything for you in an estimator for you. So that brings us to SageMaker API. So this is what typically what a SageMaker API looks like. So you'll import two libraries. Bolto is the standard AWS library that everyone uses. And then the second thing is SageMaker. So SageMaker has its own SDK. So it's independent from the Bolto library, which covers almost everything else on AWS. So you create a session, right? So you create a session. Once you have a session, you create an estimator. So the estimator provides you with the parameter, which what kind of hardware you actually be training things on. So the training instance type, the training instance count, so you can have multiple nodes as needed. You can also tell it to use spot instances. So spot instances are about 70% cheaper. So I think that's one of my favorite features about AWS is spot instances are really inexpensive. So we're able to get 70%. I think Miro and I were running this HPO testing for Rapids, something called Rapids. We were able to get like a really large amount of test for very inexpensive by using spot instances. And then there's the hyperparameters. Hyperparameters are parameters that's specific to your algorithm. So in this case, it's PCA. So you can do that for trees. You can do that for different models that you're doing. So model.fit, or in this case, PCA.fit, it starts the training job. You'll be running that today. So the training job will be pulling down the right containers. It will be starting the training job. It will be uploading the model which it trained up to the bucket. That's why it has actually has a S3. It has a bucket usually associated with this. And finally, being able to host your model. So model.deploy is the only API you would know. So essentially, three of these APIs is all you really need to know to be able to use SageMaker. So in terms of distributed training, we support Harvard and parameter server. So Harvard is more synchronized. It's synchronized. It's the underlying communication mechanism is MPI, right? And then there's parameter server. And as you can see, this is just another example. If you tell the estimator to create enable the parameter server or Harvard, you'll be able to train the models in distributed fashion. HPO is what I usually call is the embarrassingly parallel. So you're kind of doing a parameter sweep, trying to find the best hyperparameter for your model. So this is particularly important if you're deploying your models and you want that to be super efficient. So I have an internal customer that's deploying that on deploying one of their tree models on don't remember, I think it was like 4,000 hosts. So every little bit of saving would actually cause a very large amount of dollar saved total. And Autopilot is starting to become more popular. So you can think of it as Autopilot as another loop around hyperparameter. So instead of trying to do the training multiple times based on the parameters, you're doing training on multiple hyperparameters for multiple models. So the way you think about it is like an outer loop again. So Autopilot is becoming more popular for people who don't necessarily know machine learning. So I think developers are the true target. So they're able to be able to create Kaggle-like performance by simply running AutoML, or we also have an open source project called AutoGluon, which you can run that anywhere. So those are really, really competitive in the market today. So deployment. So a lot of people do training. So most people got that training down, and I think I've seen people training on 1,000 GPUs or even 2,000 GPUs. But when it comes to deployment with 1,000 or 2,000 GPUs, that is very rare. I've only seen that within the Amazon. So not very many people are doing that. So there's actually an art behind that as well. So there are two ways of doing that. One is running a batch inference, and then the other way is just essentially using a REST endpoint to be able to service this, and you can make one call at a time. So the model itself is can be deployed onto the endpoint using availability zone. It also supports A/B testing. So if you think about it, it's almost like we're doing the DevOps for you, so you don't necessarily have to. And of course, there are people that prefer to do that on their own. There are people that would use Kubernetes to deploy this. I mean, that's also fine. But we just essentially take care of all of the patching, a lot of other things for you, as we also build a lot more additional features to it. So there's another feature that we support called multi-model server. So the idea is that I can give you 500 models and essentially in a S3 bucket. So you just have 500 zip files, and you say, hey, okay, serve all of them. So whenever a user makes a request, it will call the appropriate model. So we have customers that have up to like 10,000 models that they want to serve, and I don't really understand why they would need 10,000 models, but that's what they have. And these are the type of scenarios that we're seeing. Okay. Yeah, so another feature we have is model monitoring. So being able to detect drift and other issues with the services. You can think of it as a cron job. I mean, you can certainly roll your own, but what we do is we can combine this with the debugger for SageMaker as well as the model monitoring, which essentially runs a cron job just to make sure that your models are not drifting, or the type of input data that people are providing you are not drifting away from what your model is capable of doing. So SageMaker Neo is based on an open source project called TVM. So the idea is that be able to take your model parameters and your models that you're serving and compile it down automatically to the proper hardware. So without optimization, you probably just going to be running with a high latency, and the model will be relatively large. So what TVM or SageMaker Neo does is that it takes your model and says, if I'm running on GPU, I'm going to use TensorRT runtime to convert it to TensorRT runtime and be able to run that much more efficiently. So we typically see about 2x to even 7x. So I saw I think it was a MobileNet that was much faster than everything else for some reason. And of course, all of these things are built upon the open source projects and open source ecosystem that we have. And that ecosystem includes TVM. So that's something that we support. That's essentially SageMaker Neo to be able to optimize your model. Jupyter Notebook, we support Jupyter Notebook quite a bit. One of the Jupyter founders, Brian Granger, is now working for SageMaker. So we also provide a D2L book, which is about 1,000 pages now, and it has PyTorch, it has TensorFlow, as well as MXNet Deep NumPy implementation, which allows you to be able to learn deep learning with any of those 3 flavors. And you can also use it like a Stack Overflow, where you can copy and paste code from it. In addition, we provide Gluon CV, which is for machine vision, Gluon NLP, which has a lot of pre-built models that are about 10% faster than the stock model you're going to be getting anywhere else. We also support the time series data, which implements some of the papers that we published here. Another thing I want to call out is the DGL, which is I would say another cutting edge research area, which we're starting to use more in our own services. So it's great for a recommendation system and also finding relationships at scale. Given that, I actually put some resources here. So of course, we're going to be sharing that slide, and everything is actually on the GitHub repository I showed earlier. Rachel has the Machine Learning University content on this URL. And also we have all the different Gluon services. We would love to have you participate, and also the dive into deep learning book. So Miro, I'll have you maybe do a very quick overview of NeMo, maybe even before you do a demo. So there's the 3 slides which I like you to maybe talk through and just introduce to people what NeMo is all about.
Sure. Can you hear me?
Yeah, I'll flip the slides for you. Yeah, so just let me know when it's to next slide. Yeah.
Yes. So NeMo is NVIDIA's toolkit for natural language understanding and processing, and it leverages all of our optimization techniques so that as a data scientist or practitioner, you can stay in a comfortable Pythonic environment and with a few parameter switches, leverage techniques such as quantization, which allows you to represent the weights and activations of your models with lower precision, and essentially increase the lanes on the highway, if you will, when you're doing your number crunching on GPUs. And so it also allows us to use mixed precision training and all other kinds of tricks. But as a high level overview, the way to think about it is that it's a really great way to leverage all of the advances in natural language, specifically around fine tuning and transfer learning. And so the demo that I'll show you today at the very end of the session is going to be focused on this as well. And so in this slide, This is just kind of showing you the fundamentals of fine-tuning and transfer learning, where we would have spent something like, an enormous amount of time and computational resources learning on a large corpus, and then we would take that model that has learned to fill in the blanks, let's say from Wikipedia and Google Books, and then use it to do a task that we specifically care about for, let's say, our business needs. And the benefit of doing something like this, there's many benefits. One is that you don't have to spend all of that time and resources to do the training. You're essentially starting with a very powerful model as is. In addition to that, you get to actually experience the benefits of continuing the fine tuning. And this is a interesting sort of result showing that oftentimes, even if you just do, if you skip the pre-training phase and go straight to tuning on your data sets, you can oftentimes actually find that you can decrease the error rates of your models by leveraging a larger corpus and having it do sort of a more breadth training. Maybe next slide. Yeah, and so then we'll jump into the demo at the very end of the session, and specifically what I'll try to show you with that is Nemo running on SageMaker and some interesting visualizations that show you how the learned embeddings are changing over the course of the fine-tuning / transfer learning process. And I'll hand it back to you.
Great, thank you, Miro. So I think the next section is the we're going to be going over the BERT workflow. So Rachel, the floor is yours.
Yeah, can I share my screen first?
Yes, yes, you should share your screen, yes.
Let me take a look. Okay, can everyone see my screen?
Yes, we can. Thank you.
Awesome. Well, thank you, Wenming, and Miro for the awesome introduction to NLP and AWS service. So, and the next session, next maybe 20 minutes, we're going to dive into the technical details of this NLP, especially BERT. And so here is the general landscape of performing most of the NLP tasks. So it has 3 layers. As you can see, we have those application layer from the start, from the upper side. For example, the sentiment analysis, or the question answering, or the machine translation, etc. So we have maybe 10 more, 20 more different NLP downstream tasks that we classify, that we'll handle it differently. And below that, we also have this architecture layers, which we can fit any model, the basic model size, like the basic MLP, multi-layer perceptions, or CNRNs, convolution neural networks, or recurrent neural networks, or the rising attention model, which just rising out, I think, 3 years ago. And then below that, there will be the most fundamental layers for NLP, the embedding layers, which will vectorize input tokens to a vector. So that includes 2 parts. And the first part will be the shallow layer. The first 3 are all the shallow word embeddings or shallow word representations, like the word to act, the glove, or the subword embeddings. And they're all trained based on those 1 or 2 really shallow, deep neural networks, really shallow networks. Well, on the other hand, the next tab we have is the deep embedding, which representative will be the BERT. So for the BERT, is embed a word, a sentence, or paragraph to a number of array with like this 1,000 dimensions. And now let's dive into BERT. So we all know that if we are using the traditional language modeling, which we try to vectorize 1 word, a token, or sentence, it will be problematic. So I remember back into earlier, I think after a while I joined Amazon, I saw this headline on the news. It's like Amazon is on fire. So I was pretty confused like the time. It's like, I was confused, like, do you refer Amazon like the company, or are you referring to the Amazon, the forest is on fire? And for the fire, are you referring whether Amazon building is on fire or whether like the forest is really on fire? So I'm super confused. It's just like this bird fist. And as you also know that the NLP tokenizer is pretty messy because of this ambiguity, this polysemies, this synonymous. And in spoken language, it's even worse because of this homophones, like two more words having the same pronunciations, and the sparsity is like 4 candles and 4 candles. So they're almost the same, but they have totally different meaning. So that's why the traditional language modeling has a lot of problems, and that's why we introduced BERT. So BERT's name is coming from the bidirectional encoder representations from transformer. As you can see, it's bidirectional rather than all the previous language modeling, which are only trained unidirections from left to right. BERT trained on both directions. And also, BERT is built and used as transformer encoder. So it was trained on those whole transformer model, encoder, decoder architectures. And we'll dive into the details of transformer later. And then BERT will just bring out, extract the transformer encoder layers and use this to do the embedding. And that's another amazing thing for BERT is task agnostic. So what they are going to do is you just like add one extra layer based on your downstream NLP task, no matter whether it's a prediction, it's a classification task, you probably need one neuron add-in. And or if it's like a question answering task, you probably need add multiple neurons on the context. So it's based on different tasks, but the total embedded layers can be used for all those different tasks, and it will be shareable. And what the most amazing thing is like when it's launched back in 2 years ago, so like October the 28th, 2018. And it's improved 11 NLP tests to the state of art, which is super amazing. So that's the BERT, and I just said is BERT is just how this like transformer encoder. As you can see, the transformer encoder contains a lot of like transformer block, which we'll dive into deep the details later. So why we are using transformer? So you probably have been heard like CNN and RN a lot of time, and transformer probably a quite new idea for us. So CNN and RN, they all have their points and cons. So for CNN, the convolutional neural networks, they're super easy to be parallelized for training at one layers, but they cannot really capture the sequential dependencies between those tokens. Well, for RN, it can really capture the sequential information, but since each of the tokens is like passing sequentially, you have to wait all the previous tokens being passing and being extract the features into your memory. You can pass in the next features. So it cannot really be parallel to train. So to combine the advantages of both the CNN and RNs, Vaswani et al. Back in 3 years ago, they designed this novel architecture called attention mechanism. And they call this architecture transformer, which achieved the parallelizations by achieving the recurrent sequence with this attention, and at the same time encode each of the atoms' positions in the sequence. So they encode their position through this positional encoder, but also a parallel passing using this multi-head attention layers. So transformer really leads a compatible model with really significant shorter of the training time. So why it called transformer? Probably because it's super complex. It has like this encoder decoder architectures and just like assembling all the different parts like the transformer in our movies. So as I just mentioned, transformer has this encoder on our left-hand side and the decoder architectures on the right-hand side. So both of them have the similar architectures. As you can see, both of them have the embedding architectures, and then it will passing through the positional encoding. And then it will pass this like transformer block, no matter on the left, which have like a probably shorter transformer block, and our right, which have 2 more layers of the transformer block for the decoders. So in the encoders, the source sequence embedding will be fitted into this n different repeated blocks. As you can see, there are n repeated ones, and each of these n repeated blocks will be connected to the decoder blocks individually. And in the decoder, the target sequence embedding are similarly fitted into this n repeated blocks, and then the final output finally outputs by applying a dense layers, and this dense layer usually depends on what kind of downstream task you are going to use. So let's dive into the details. Since like the encoder and decoder blocks have roughly similar architecture, we'll just focus on the encoder now, and this is what BERT use. So we can decouple the encoder blocks into 2 folds. So the transformer block is like this huge chunk, and we also have the positional encoding. So let's start with the positional encoding. This is a little bit simpler. So for a question of transformers, how do we really record each token's position in a sequence? Since for any of these functions of these layers in the transformer block, none of them really trying to record and distinguish different tokens in order or in a sequence. So that's why positional encoding has this power. It will use some like sine and two-sine mathematical functions to try to encode each of tokens positions in a sequence, and it will add this sequential positional information back to the embeddings to record each token's informations. And how about this transformer block? So the transformer blocks, it contains mainly 3 parts. And the first part is this multi-head attention. You probably have heard attention multi times, so I won't tell too much details, but basically it just like have this 12 different single head attentions parallel training at different tokens. So after the multi-head attention, as you can see, we have this add and norm layers, no matter after the multi-head attention or the positional wise feed-forward neural networks. We have this add and layer normalizations. Basically, we parallel train those attentions or those FFN. And what we do is we kind of add all those features together and have this layer normalizations apply on it. So layer normalizations idea is like the batch normalization. Well, batch normalization will try to normalize within a batch. Layer normalization will try to normalize within those layers. And another component is the positional wise feed-forward neural network, as you can see here, which is also appear in the decoders. And this is basically just like some simple NLP or feed-forward neural networks, but it's applied on each of those token positions. So that's why we call it positional wise. So I won't talk too much in details, but detail, like the book I'm going to introduce at the end of my presentation, it have all these technical details, include the theory on the math, and like if you click it, it will bring you to the section of transformer. So we have talked all of the component in details, and we also code them in, I think here we only code them in MXNet, but later we also incorporate PyTorch and the TensorFlow implementation to code on the transformer from scratch. So now let's back to our slides. So as I just mentioned, like BERT is kind of embedding layers. So rather than like the traditional embedding, which only have the token embedding, BERT have 3 parts that sum up to be added into the final embedding. So the 3rd part are the token embedding, the segment embedding, and this positional embedding. So for BERT, let's start with the token embedding, which is the most traditional classical ones. As you can see, for each of the token, for the CLS, it means like the task, the classification task. And we have each of the token added in as E of this token, which is the embedding of this token. And we also have a SAP, which is SAP, or the separator between 2 sentence or 2 sequence. And we have this token embedding for each of the token coming in. And the second embedding, we also call the segment embedding, because for BERT, it probably have like a pair of text coming in, and then we will need to separate those two sequence. So we'll have them embedding as A or AB, and etc. And then on the last layer, we also have this positional embedding. We want to embed each token's position from our positional encoding. Remember, for our BERT encode architecture, before that, we have this positional encoding architectures, and that is like using the sine and cosine function to encode each of token's position, and we'll add those embedding information back to our final sequence embedding. So that's how BERT generates its embedding. So again, I won't talk too much detail of the BERT embedding or how to architecture BERT, but if you want to say how BERT is trained from scratch, feel free to check on detail to see all the code, all the math, etc. So that's a BERT. Well, if you just want to use BERT, so there are mainly 2 folds of usage. So the first fold is like you can just grab the BERT parameters, and you can just like go ahead and train it. You can just add 1 additional output layer up on the BERT model based on different NLP tasks. It can be 1 neurons for the classification task, or it can be multiple neurons for like maybe Q&A tasks, etc. So this means we do not really need to train a lot of the parameters, but we can just benefit from the pre-trained parameters and train our last layers. So this is 1 layer, and the next layer is the fine-tune method. So the fine-tune method, what we are going to do, we also need this 1 extra output layer. But since probably our task and our dataset is a little bit different from the pre-trained dataset, like BERT is using this 3.3 billion of tokens from books and Wikipedia, probably you're going to have your maybe healthcare dataset, like which have a lot of like COVID-19 in it, and which will be super different from the existing pre-trained dataset. So your parameter will probably be a little different, your token probably a little bit different. And so that's why you can use this fine-tune task to fine-tune all the existing BERT parameters. And also you will train your last output layers from scratch based on your output downstream task. So we are talking about how to fine-tune BERT in our lab in just maybe 30 minutes. So this is our whole family of BERT. So after BERT published in late of 2018, which brought a huge enthusiasm in both academia and industry. So after the BERT paper, you will see all those BERT family, like Roberta, like this Ernie, etc. So BERT, as I just mentioned, is quite of small. Consider now all this huge, like the GPT models. Like BERT is only trained on this like 3.3 billion of book and Wikipedia dataset, Well, then if you can see Roberta is trained on like 10 times larger data set with maybe 5 or 4 times longer times, and it's a much larger model. Well, GPT-3 is even huge. So GPT-3 is a little bit different from GPT's models. It's a little bit different from this BERT modeling. So BERT is basically using the transformer encoder, and you will need to add some extra layers to decode the encoder's embeddings. Well, for the GPTs, they are totally different. They're using the transformer decoder, which means it's really task agnostic. It will output anything if you just feed in no matter what kind of task. It will output directly. You do not need to fine tune anything. So that's the power for GPT. But you probably heard of it, like the GPT-3 is like 175 billion, like the largest model is 175 billion parameters, which are super huge. So if you want to host it, you probably need like 700 gigabytes of memory to host the GPT-3 models. So that's probably a little bit problematic if you just want to use your own GPUs. And so again, GPT is like those autoregressive models. Well, BERT is a like autoencoder model. So that's probably the main difference. So that's basically all the families of like those semi-supervised pre-trained NLP models. So now let's back to our NLP workflow. So we have been talking about BERT a long time, and now, especially in the next section of the lab, we're going to talk about this NLP downstream application for question answering. So I believe most of you have been familiar with this question answering task. So for question answering, we will have 2 pairs of input. So we will have a question, and we also give the model a context. So for example, we probably can ask us this question, or who shall use DTL? And then we'll give model the context for the model to answer this question. For example, the answer might be dive into deep learning or DTL, detailed level AI. It's an interactive open source deep learning online book with this code, math, and discussion. And it is designed for this engineer, researcher, and students to learn the state-of-art deep learning models. So to answer this question, as a human, we all know that it will be engineers, researchers, and students. But how does the model learn? So the model will try to index each of the contexts from 0, 1, 2, 3. And for each of them, finally, what QA model will output will be an index. It will be output a start index and an end index for the final answer. So probably this index will be 20 to 23. So the model output will output like the 20 to 23, and then it will be mapped back to our passage context of the exact index and try to extract the tokens from our context to give us the final answers from each of the tokens, the engineers, researchers, and students. So that's the QA modeling. And now let me introduce a little bit for DTL. So dive into deep learning basically is a free open source platform that it can actually be used as a textbook and the reference books at Berkeley, SMU, MIT, Stanford. And I think now it's more than 100 universities. I should update the slides to be honest. So more than 100 universities worldwide have been used DTL as a textbook. There are different varieties, of course. And especially, we have been teaching one class just based on the whole workflow at a Berkeley class. It's called Berkeley 157. So if they click the link, it will brought you to the main link for the Stat 147 last year. So I'm also a TA there. And this class is taught by Alex and Mu. So we have our videos record, our textbook, our discussion forum, and previous assignment that the students were trying to answer. And if you are going to use this course for teaching, or if you have a study group, feel free to contact me if you would like to say the homework answer. And we also have our syllabus list here clearly from that course. So now let's back to our slides. For the details, it is well covered from the basic stats, from the optimization methods, machine learning basics, and also we teach you how to do the parallel trainings on GPUs. And detail, we have now more than 150 roundabout Jupyter notebooks. And remember, this 150 is just for one framework. So now if we have 3 frameworks, it will be maybe almost 500 notebooks now. And it also have different model architecture cover. For example, like the BERT, we just talking about the transformer model, attention model, and also the basic CV models and NLP model. We also will cover them. Last but not least, if you're not a native English speaker, you prefer to see the other language, we also have the Chinese language, the Korean language, Japanese language, French language, etc. And so actually, detail have been well endorsed by a lot of industry leaders like Jason Huang, who is the president and CEO from NVIDIA. He said like detail it's an excellent textbook on deep learning and deserve attention from anyone who really wants to learn deep learning, because deep learning has really ignited this AI revolution, which will be really powerful for technologies in our own time. That's like the 4th industry revolution. And also detail is really mobile friendly. And we also have different formats. We have this mobile format. So if you're on a subway, probably you're not like need to on subway this time. But anytime you can just use your mobile to learn the coding. Probably you cannot run the code. If you really want to run the code, we also provide you different versions to run on the AWS EC2, on Google Colab, on AWS SageMaker, or you can also run locally. As you can see, it's like a local host in this page. And you can just run the code, but we would recommend you to have a GPU to run your code smoothly, rather than waiting there for like 12 hours for code for a model to be finished. And the last, I will have this like Gluon ecosystem. So this Gluon ecosystem, which is DTOs live in, like the Gluon whole family. We have the Gluon CV, which have more than 200 pre-trained computer vision model with high performance. And similarly, we have this Gluon NLP, which is just for natural language, which contains the state-of models like the BERT. We pre-trained it, it can just grab and use. We will also have this Gluon TMs for time series prediction. And I think when we just mentioned this DGL and TVM, which is one for a deep learning on graph, as graph model become more and more popular these days, we build our graph infrastructure to support you to fast train it. Similarly for TVM, which is a great deep learning computer, which enable you to obtain the minimum deploy models on a diverse hardware backends. And it supports not only MSNet, but also PyTorch, TensorFlow, etc. So any question before we run into the lab? Feel free to open your camera and let me see you. That would be great, rather than I'm like staring on my camera all the time.
Hi, my name is Yash Perga. Thank you for this introduction. I have a question regarding this lab. So let's say we kind of learn how to use like a either a pre-trained BERT model, or we can train our own model. What happens when something goes wrong? Are you guys spending some time on how we can actually debug a very complicated system like BERT model?
Yes, that's a good question. So, Wei-Ming, you want me to answer? I would just go ahead first.
Sure.
So that's a really good question. Debugging is probably the most hard part, I would say, especially I remember back in 2 years ago, we were trying to debug the TensorFlow version 1. It's like super hard to debug. And so for SageMaker, it supports different versions. Like SageMaker, you can train and deploy at the same time using the same instance. But also at the same time, you can also train your notebook, but deploy only. So what you're going to do is like the other Jupyter notebooks, you can train your models trying to debug. It will just return you the normal either PyTorch or MX notebook, which is easier for you to debugging. And after you train the models, you can just load them yourself manually to the S3 bucket, and then you can call the SageMaker deploy to deploy that model. So which in this ways, you are just like locally training using a like local machine. The local machine means like probably some GPU or some type of instance on AWS, but not like using the SageMaker for train. But if your model is pretty mature, pretty ready, you can also call a script like what I'm going to show you in our lab. It's like we're just call a pretty mature script to train a BERT model or fine-tune a BERT model, and you can then deploy on the SageMaker. Did I answer your question? Yeah, go ahead with me.
Yeah, so another thing you can try to use is something called a SageMaker debugger. So we do provide that tool. That tool is specifically built into SageMaker Studio. I'll send a link to some slides which you can take a look at. So the idea is that you can output tensors and look at the details of if something is not converging, among other things. So there's some built-in rules that SageMaker Debugger provides. But again, it's relatively new. It's not, it doesn't do everything for you, but it does do some of the more common basic things that you probably would have a hard time doing on your own anyway. So it's still kind of a work in progress. But I'll send a deck in the window. And my confession is that I had 780 some slides from various presentations, and there's a lot of details we have to omit for this lab, but I'll send that particular one in the chat window so that everyone has access to it. So we do have time for some additional questions, but in the meantime, I did put the lab link inside the chat window, and it's something called Event Box. It's and once you click on it, it will go through the process of verifying you're not a robot. I know that well, it's kind of hard to tell whether you're not a robot these days. So you'll click on it, and then it will start the AWS environment. And the GitHub has very much self-explanatory instructions, and I will kind of walk everybody through the process as well. So for those of you,
please go ahead, share your screens. I will just jump out.
Okay, yeah. So this is the first link. Oh, actually, let me just share my screen now.
You can just steal from my side, right? Or do I need to stop first?
I think I should be fine. I just have to figure out which screen. There's like 17 different screens that I'm looking at. Yeah. So okay. So let me share my screen. Okay, great.
Awesome.
Yeah. So this is let me actually get out of PowerPoint. There you go. So for those of you who just got on, we have two links. So the first link is this, and you already have it in the chat window. So just click on this link. That would bring you to a page called Event Box. So there's your event box, and just say you're not a robot. apparently it just let me do that. So once you launch that, what will happen is that it will deliver a hash to you, and then you go into an AWS console. So I provisioned enough capacity for everybody, so it shouldn't be a problem. And then basically just click on the console there and open AWS console. So this is the same same instruction of what is in the KDD lab instruction. So if you're not able to keep up with me, speak up and just let me know. I'll slow down a little bit. But this is the same instruction that I'm walking you through in the GitHub AWS, which I just put in the chat window. So this is the same one. So go to Events Engines, you already did, and just open the AWS console. So I'm already in the AWS console. Oops, let me do that again. So for those of you who are not familiar with AWS, I wanted to explain a little bit about how the system works. So this is the AWS cloud, and it has a lot of different things in here. You know, you would be able to. So there are probably, you know, I don't know, almost 200 services that we have running here. The main things are, you know, storage and compute and EC2. So if you type EC2 here, you'll be able to find, you know, EC2. You can provision your own virtual machines as needed, but we're not going to do that. So we're running something called the AWS SageMaker, which essentially abstracts away everything for you. So we're going to go into SageMaker. And then also there's, you know, S3, which is the storage engine. So in the account that you have, it's actually very powerful. So I provisioned enough resources for everyone to go around. So as I go in here, you'll see, you know, if you go into SageMaker, there's SageMaker Studio, which gives you the new experience. So we're not doing that today because SageMaker Studio doesn't support Docker inside the actual notebook yet. So we're going to use the classic notebook instances. So on your left-hand side, so if you're not able to keep up, definitely, you know, slow me down. And also, you know, just, you know, type in the chat window. Rachel, as well as, you know, Miro would be able to help, and Liam is, you know, also here to help. So just click on the notebook instance here. It should be relatively easy for you to be able to do. So let's see. So go on to click on the create notebook instance. So let me explain a little bit about how this works. So you're going to need a name. So I'm just going to put Wenming, KDD. I don't know, how do we differentiate today? So this is August 8. Today is the 25th already. So 8/25, I'm not going to put any dashes. So and then you can pick a notebook instance. So AWS provides all kinds of you know, instances, and then you can use these instances for notebooks, for training, for hosting, you know, anything you want. And then let me, you know, just explain a little bit about these different type of instances. Because, you know, for me, it's like, I know this, I've been using this for 4 years. For a lot of people, it's not necessarily, you know, the most, you know, not familiar necessarily. So T means that they're burstable. So these are, you know, essentially shared instances of, you know, like a CPU instance only. And then you have these M instances, which are optimized for memory. So we used M instances for training really large tree models on CPU. So I was using a lot of these. So M5 24x large is probably, you know, it has like, I think it has like 300, 400, almost 400 gigabytes of RAM. So these things can go all the way up to, you know, a lot of memory. So there's M4, that's the last generation of large memory instances. And then you see the C5s. The C5s are optimized for CPU instances. So I would like you guys to pick the C5 2X for this particular one. And of course, there's GPU instances. And then there's, you know, the P3 2X, among other things. And if I mean, it doesn't really matter what you pick, but try to pick the lower instances. So either the C5 2x, that'll be more than enough for what you need. Or if you're more adventurous, you want to do like a GPU instance for the notebook, feel free to pick the P3 2 extra large. That will give you a Volta 100 GPU on your notebook instance. But for the purpose of training, you don't necessarily need a GPU instance. It's mostly for people who have the notebook that's not already optimized for training remotely, so they can just want to try something out without creating like a container for it. So what I am going to do is I'm going to go pick a C5 2 extra large here. Okay, so hopefully I'm going too slow, not too slow. So, and for elastic inference, elastic inference is something we built that allows you to attach a GPU that is remote to a CPU instance. So in this case, I'm not going to do that. There's some additional configurations that you should set. The most important one is you want to set the EBS volume. EBS stands for Elastic Block Service. And what it's doing is essentially serving as a kind of a remote hard drive for your instance. Let's just say your instance fails or something bad happens. That EBS volume is always going to be there. So when you stop your instance, you start again, the same EBS volume persists of everything that you have saved. So I'm going to make that 50. And they're usually very high performance. And the team role is fine. So for those of you who are not familiar with IAM roles, it's a way of setting permissions. You can think of a role of being someone with a keychain. So that's like a visual way of explaining that. So I have a keychain that I have all these set of keys. So let's just say I change my job tomorrow. So Rachel is going to take that over. She just takes over that role. So Rachel and I are users. Roles are, essentially the permissions that you have. That it's like a keychain. So that's what a role is. So I'm going to use that, leave that as a team role. So I'm going to give root access to everyone. And in terms of Git repository, you're going to take the instruction from my AWS lab and just copy this, this instruction over here. So I'm just, purposely going slow so that everyone can follow. So this is one repository. You just basically select clone a public Git repository. So I will click on it and create notebook. So I don't think I missed anything. So let's just review here. So name, C5 2x large. Make sure you have 50 gigabytes of space. Team role is perfectly fine. And then you're gonna git clone that repository and create the notebook instance. Woohoo, yeah. So it will start that process and it will take about 5 minutes or so. Maybe 3 minutes. So think about what it's actually doing underneath. It's provisioning. So it's a ECS container. It will provision. It will pull down the image that is default. Let me also explain how the notebook works versus the training instances versus the hosting instances. So the notebook instance doesn't actually allow you to be able to use any random containers out there for obvious reasons. That's kind of the command control center. But what you can do is you can do lifecycle.config in the previous session. So if I were to create a notebook again, so in here in the previous row, so you'll see that there's a lifecycle.config that you can do. So here's a lifecycle config, and what you can do is you can put a script in here. The script can do pip install a bunch of stuff. So in fact, the events engine, so the stuff that we're using today to provision all this, I can actually give it a script and say, hey, go provision these notebook instances with all of these items configured, including pip installing, for example, Nemo. That's what we actually earlier decided to like try to do as a lab. You can install the stuff for Nemo. You can install the stuff for D2L. You can install the stuff for Gluon. You can install whatever you need in that notebook instance by only configuring that once. But for the training instance and also the hosting inference, that doesn't actually matter because you can just use Docker to build a container, which you will see in a lab, and then simply deploy that. All right, so hopefully that was clear. And let's actually go back to see what's happening with my notebook instances. It should be provisioned by now. It's pending, so it's still kind of going. And also, sometimes it's a little slower because there's a lot of people provisioning at the same time, potentially. We're all at US East. It shouldn't really be a problem. So 5 minutes usually takes about 5 minutes or so. Any questions at this point? Feel free to unmute yourself, and you may be asking a question that everyone else is going to be asking, but not maybe too shy to ask. Any questions? Hopefully it's clear. Good. Okay. So we'll just wait for the instance to actually keep going. While this is actually happening, I'll kind of give you a little tour of what additional things that's available. So there's, AWS Marketplace, and it comes with a lot of different models. There's AI augmentation. So the idea is that you can actually have a human in the loop for the review workflow. There's all these different endpoints configurations that you can do, including multi-model server. Sorry, I'm trying to see what was said on the, what is the format? What is the format to the lifecycle? It is JSON, yeah. It's pretty simple, yeah. And also, I actually have good news. I was just, someone was just texting me. Our marketing department was just texting me and saying that they just got approved to give everybody a $75 AWS credit that you can use in your own account. So that's really, really generous of our marketing department. What I like to ask you to do is just send an email to me. Just send an email to me. Oops, sorry. Am I sharing my screen properly here? Yeah, so send me an email. So that's my email. So let me also put that in. So I will send you, I'll send you a $75 hash code. So that's my email there. And the hash code you can put in your account. So you can go, so not on this account, obviously. This account is, I'm provided to you. After 3 hours, we'll be shutting it down. So you would go into my account, and you will go into credit. Hopefully it will, go into credits, and you can add the credit hash that, oh, I don't have permission here, but you would go into here. So what I would do is I will just take a screenshot of this so that we have it in the chat history. So just go into copy to clipboard, and then I will paste it in here. Hopefully. It doesn't seem to paste images, but I'll just type in the chat window, which is account credit to add $75 credit for your own AWS account. Just email WYE. Yeah, so it's one of the great things about working at Amazon is that we do things really, really quick. I asked Jeff, our marketing folks, like literally last night, and he goes, you're asking me like what at night, so we'll try. And so he was able to get that done. So very much appreciated, Jeff. So let me go back to the system here. So I already have it. The notebook has been provisioned. So I'll go into open the notebook here. So I just simply chose Open Jupyter instead of Open Jupyter Lab. You can do either. I mean, it doesn't really matter. So there's a bunch of notebooks here. So the one that we will be doing is the BERT fine tuning on KDD. So that originally came from the SageMaker sample examples directory. So if you go to SageMaker examples, we got all kinds of different examples, which you can start with. So there's, SageMaker debugger right there. Examples currently not available. That's interesting. So a lot of these examples, so maybe it will have to refresh a little bit. So once I refreshed, the examples will show up, and maybe I'll show that later when my instance is running properly. So going back to file, so go to BERT fine tuning. So you'll see the notebook running. So what I will do is I'll kind of give you an overview of what this notebook is actually doing, and then Rachel will go into some of the details for everyone, and I'll go around and answer questions as needed. So the first thing is that in order to train this BERT model, is that you'll download a pre-trained model first. So once you've gotten that model, so once you've downloaded the pre-trained model, you'll build a Docker container for it. So machine learning and infrastructure kind of go hand to hand, and a lot of our data scientists actually struggle with these infrastructure things. But I think SageMaker makes it relatively easy to do. So as you're building the containers, so the containers will be installing a few extra things, and you'll log into the ECS account. Once you've done that, you have to actually set a bit of a permission. So you'll have to go into the access link to go to ECS permission to give yourself permission for it. So just remember, this is one of the steps that you're going to be doing. And then once you build the container, you push that container to the ECS registry so that the training accounts can actually download all of them. So we'll actually prepare the instances and making sure that container is ready to go. And then you'll build the hyperparameters specifically for that model with 4 GPUs. So remember that hyperparameters is specifically for that model. And after that, you'll build a estimator. The estimator is in this case is just PyTorch. So you will select what type of instance type. In the P3 8 extra large has 4 V100 GPUs on it. And also, by the way, I forgot to mention that our Ampere or A100 is actually coming. I don't know when, but in the next few months, it's coming. So that is the latest NVIDIA GPU. I get very excited. I know Miro is also very excited about it. But it's definitely coming. It's going to be at least 2.5x faster. And I have more memory, and everyone is excited about it. I will have faster networking, and I think I'm going to be very happy. Once I get my hands on it, and then once you created the estimator, you give it the type of GPU you want, give it the framework version, and then you specify where the model is in the S3 bucket. There is a default S3 bucket. There's no magic. There's a default S3 bucket each SageMaker when you create it. So there's a default bucket there. So it's not like there's something that's magical here. And then you'll run the torch.fit, which is essentially the training. It will train for about 20 minutes. The training is real. And the training, you're not necessarily going to get access to 4 GPUs that easily, but AWS does provide that to you. So I think for the spot instances, not spot instances, if you use spot instances, it gets down to maybe $1 per machine to host. So in case this is like 20 minutes, 15 minutes, so it's $4 or $5 worth of training if you use spot instances. So it's not that expensive, and it automatically shuts off when you're done. And then you also have the then we'll deploy the model. So I'll let Rachel take over and maybe explain some of the details of the fine tuning from the science perspective, and I'll go around and help people if you're still having issues. So Rachel.
Okay, great. Thank you, Wenming, for talking through. So let me first share my screen. Is you all?
Yeah, I'll let you share. I'll stop sharing mine. 。 . 。 。 . 。 。 . 。 。 . 。 。 . 。 。 . 。 。 . 。 。 . 。 。 . 。 。 . 。 。 . 。 。 . 。 。 。 . 。
。 . 。 。 . 。 .
。 . 。 .
。 Okay, can everyone see my screen? Okay, cool. I believe you can all see my screen, right?
Yes, we
Okay,
can.
so I believe we may have talked through about, so I just launched a new instance with everyone. And we're just going to dive into deep of fine-tuning a bird using PyTorch model. So you just click the script, bird PyTorch fine-tuning. And I just run those as long as Wumin just show everyone how to use it. So I won't be verbose here. So what I'm going to do is like import all this package and all those pre-written script. So some of the script here about how to train a bird model, how to encode bird's features, etc. And they're all living in the same folder if you're interested to it. And so I also like just download that pickle file, which is a pre-trained pickle file. As you can see, it should be living here. The bird-based data is pretty huge. And then after that, as Wumin just showed us how to build a Docker. So we just like run this like Docker containers. So the Docker container was built based on the Docker file. As you can see here, we have our Docker file, and basically it's just tell the Docker what kind of image, maybe some pre-built image that will download some PyTorch and other package, and also what will be the path for the SageMaker's models to come in and train the models and upload the models or deploy the model, etc. So we just built that containers. It probably took, I think, a couple of minutes. Oh, it's like huge. Oh my God. Let me just fold it. So as you can see, it probably take a little bit time to build that model. Sorry, where we are. We're here. And then what we're going to do is we first need to give the ACRs permissions for our just built image. So what we're going to do is like you click that. It will bring you to the ACR instance for that image you just built. And what we're going to do is we're going to add this policy JSON. And this policy JSON will exactly be from here. So what you're going to do, you have this row run, you get your IMI. So everyone has different IMI. And what we're going to do is like, what we can do, replace that IMI with your current row, as you can see here. So replace it, and you just copy paste it to your ACR, and you added the policy here. You just copy paste it exactly besides just replace your rows for your AWS IAM. And you click save. Or if you do not really want to copy paste, you can also edit it. It will bring you to some edit page. Since we feel like the policy JSON will be simpler, so you do not need to hand pick whatever you want. But you can also do it in this way too. So now you grant the permission to your repo. And now let's come back. So now we are ready to push the Docker image to the container. So we can run the following lines. As you can see, we run this push file. So basically, it has like 5 lines. The first line is all got the different names from your algorithm names, which is your repo's name. Like here, our repo's name is bird train KDD over here. And our account name, which will automatically grab it, our region name, which should be US is 1, and then it'll come up with a full name, and we'll pass the full name to the Docker to call this push. So this line will probably take a little while, maybe 2 or 3 minutes to run it.
Rachel?
But just be patient. Yes, go ahead.
So there's an ask if you can slow down just a little bit. Yeah. And also, let's see. So I think Emily got an error saying that the policy is invalid. And there was someone else said, I can't find notebook within the KDD folder. So let's try to address some of these.
Okay, sure, definitely. Sorry, I didn't aware that I was going too quick. So to find the notebook first, if you go to the SageMaker, it probably will give you the KDD 2020. If you clone that when you launch the instance, if you didn't clone that, if you didn't say anything here, another simple way you can do is simply open your terminal, and what you can do, you can just manually clone it. It can be a public repo, it can be a private repo. So what I'm going to do, you just copy the git link over here. You just copy paste on this guy. And back to our terminal. So how to open terminal? Here's a new button over here. You click that new, and here to the bottom, there's a terminal button, and click that. It will bring you to a new terminal. So you can see the terminal 2, we have the terminal 1, so either of them. So first, I would suggest you to cd to, so let's say where we are now. So let's do pwd, so we're on the EC2 user. And if we do ls, you can see the SageMaker folder. So we'll just cd to SageMaker. And then if you do ls, you can see the KDD 2020, which I already cloned when launch the instance, is here. If you didn't see it here, you can also git clone it. You just do a git clone and copy the git link. I think it's already exists, so I won't just clone it, but if you didn't see it, you can just like git clone that in your terminal, and you should be able to see that folder after you clone it. So after you clone that KDD folder, you will just come in and you click that bird find to KDD. So that folder, you come into that, and our script is exactly living in this folder. It's called bird PyTorch find to.
So Emily, were you able to get that? Oh, sorry, Janos. Were you able to get the notebook?
I think I'm sharing the screen, so I
Yeah,
cannot
you are. Yeah,
see
you're fine.
it.
Yeah, I'm just working on it. Just one more
Okay,
second.
great. Yeah. So for Emily, if you are getting an error, so just try to copy and paste the policy again. So you need two parts. One is the JSON file that Rachel was showing you in the policy section. And you also need the results from line number 9 to, I mean, for me, it was line number 9, that it gives you an ARN and you take the ARN. Yeah, that's right.
Exactly. So this
yeah.
line, which is my
Row,
line
yeah.
number 6
6,
here,
okay, yeah.
is like your SageMaker have different roles, everyone's different role. You need to call the SageMaker, get your execution roles, and that is like help us to predict someone's hackers account. And you will give the permissions that you exactly your role can run train deploy and push this image to the SageMaker somewhere. So what you're going to do is like you just get this row, you replace with this permission line. So you can just like double click this line to replace it. And it's just like replace this file. So everyone should have different team row number over here. What you're going to do next is like you copy exactly the JSON file to this. You just like right click.
Yeah, the access link. You want to show people the access link? Okay, cool.
And what you're going to do, you access this link, which is the ACR permission link, to edit the policy. So you right click that link, it will bring you to the Amazon ACR. I will just close the previous one. So you can see my permission currently has one row, which I just edited. And what you're going to do is copy that policy JSON. And if you feel that is still has error, another thing you can do is like you can manually pick it. you can just state any name for your statement name, and you specify this as allowed. And you have a principal to be yourself. And you can find your MI as your team role. You can just search your team role here. You click that team role, which I already clicked it. And you just save it. So that's all you need to do. So you have this allow, and you find your team role, click that, and save it. So bring it back will be same. It will be exactly the same as what you do to edit this policy, which you have this like effect with allow. And as you can see, I think is everyone clear with that? As you can see, I just run my push to the Docker container. It took a little bit time. It took around 3 minutes to push this container. And after the push, we are ready to build our model and train, fine-tune, and deploy it. So what are we going to do?
Rachel, sorry to interrupt.
Yes.
In the meeting, people were saying that they were having it's taking them a long time to run block 3 and 4. Maybe you can just show them what 3 and 4 is doing. So it should take a little bit of time, but not that much time. And also depends on the instance that you provisioned. So if you provisioned a C5, it shouldn't take too long. So how's everybody doing? Okay, so it took you about 200 seconds. That seems about right. Maybe, it's also because, these are, it's dependent on the situation. So maybe the network is busy or something is going on. So how's everyone doing?
Okay, so regarding the GitLab repository, it looks like that even though I tried to enter it at the beginning, it didn't take it. That's why I don't have access to those files, but I tried to clone the way how Rachel just described it. And it's asking for some kind of a username and password to clone it. So I currently can't access the Jupyter notebooks. Can I actually just go back and edit my my notebook instance and add the repository again?
I believe what you can do is, can you see my screen? Can you see my terminal now?
Yeah,
Yes.
we can see your terminal, yeah.
So what you can do is you can just open your terminal. So can you open your instance now? So if you go to SageMaker, sorry, let me have this. You can just open the Jupyter over here, and that will bring you to the next terminal, which is here. You will see the whole SageMaker
I do not see your screen.
Jupyter notebooks line. What's that?
I'm not sure if I'm seeing your screen changing. I only see a bash terminal right now without any.
You cannot see my screen?
So so Rachel, we're only seeing your bash screen, which says git D2L. That's it.
Yeah,
Oh,
I think your
really?
screen is not, okay, now it's changing.
So you cannot see the screen?
I can see your bash.
Let me.
Yeah, you're sharing like your D2L prompt.
Really?
Yeah.
That's super weird. Let me. Sorry.
Why don't you like reshare your screen?
Yeah, sorry
Just
about
reshare.
that.
I think you're trying to switch between the
Zoom is
screens.
a bit weird.
Yeah.
Yeah, I don't know what happened.
Okay, so let me actually look.
Would it be faster if I went back and tried to rebuild a notebook instance with a Git repo link in the beginning?
Yeah, you can just go rebuild your container. Reboot your build your notebook instance. Just redo it and just create a new notebook instance. Shut down the previous one. Just do a new one. And while we try to figure out the screen sharing here,
Yeah. Okay.
or you can just use git
Can you see
clone
my screen now?
HTTPS. Yeah.
Because git clone
Can everyone
require
see my
username and
screen?
passwords.
Yeah. Also make sure
Yes,
you're
your
in the
screen is
SageMaker
fine.
directory.
I was. Yeah.
Okay.
Okay. I'll just stop.
Hey, women, can you see my screen of this terminal here? Or no?
Yes, you're fine now.
Yeah.
Awesome, awesome. Sorry about that.
It's a Jupyter
So,
terminal. I can see it now. Yeah.
yeah, so it's a Jupyter terminal.
Yeah.
You know how to open it, right? It's
Yeah.
like you open on
Yeah,
the
I've done
right
that.
hand side, and there's a terminal. We do just like git clone my repo.
Okay.
Just git clone it. It should be there after cloning.
Okay. Yeah, so I was using another one then, apparently. Okay, I'll try. Well, now it doesn't matter because I already shut down my earlier one.
Yeah, no worries, no worries. You can still follow as like we have plenty of time for you to run your notebooks. So no worries about that. And let's come back to our fine-tuning notebook. So does anyone else have questions? Sorry, I cannot really monitor and talking at the same time. I will try to.
So, Rachel,
Yeah, we're
one
good.
question is that what have we done so far? What have we actually created?
So what I haven't done is just create an image for our model. Like if you want to host your image, right, you need some environment, and you probably need a bunch of a list of different package. And what we already do, like if we deploy locally, you need to have some like maybe something like the Docker, the local environment. You pipe install all those environment inside. And what we're going to do now is like we are going to deploy on the remote instance using the SageMaker deploy, right? So we need to build the environment Dockers to host that model before we train it. So what I do is like we build the image first. So on the first line, as you can see, we create this Docker container, but first the step one is build this Docker containers. Like we build this locally, local image. We download everything. We have this image ready. And then we grant ACR the permissions that we can push our instance to the remote repo that being hosted on ACR. And here are all these ACR repos that let's see here. As you can see, I only have one, but you can have multiple thousands of repo if you like. But be sure to grant the repos permissions from here. At least like yourself, you should have the permission to that. Good question. Any other question?
So has anyone finished running the container push? And looks like a few people did, yeah. So after we started, okay, that's great, yeah.
Awesome. Okay.
Yeah.
Then I will just go ahead.
So Rachel, maybe
No
you can
worries.
explain the hyperparameter part. So where's the BERT model and maybe the workspace opt ML models, maybe just explain that a little bit in terms of the hyperparameter max length, learning rate, among other things. We're running that one epoch, so you might want to explain that a little bit.
Yeah, exactly. I would suggest if you have done the push, I would suggest you go ahead and train that first. So you go ahead and run everything first, and I will explain after you click that run. So we run this like hyperparameter style, and we build this BERT model. We build this PyTorch model. So this is like a SageMaker SDK model. I will explain it in a bit later. So you run that. That won't take a long time. But this line, the following line, as you can see, it probably takes like around 20 minutes to run it. So let's get ahead earlier. So this is really how do we fine tune the model. As you can see, it's pretty simple. So let's like test the time to run it. Okay, no worries if you're still pushing your image to the Docker or you are running it. We are all waiting here. Like this line will run like probably 20 minutes. So let me come back to explain this hyperparameter cell. So what does it do? As you can see, it's like a dictionary, and it specifies and to tell our model all the hyperparameter need to figure out. So basically, it's for SageMaker. So first, as what kind of BERT model we are going to use? As you can see here, it will be used the BERT base model. As you know, the BERT has this base model, which is a little bit smaller, and it has to give the BERT large, with a bit of large model. And the vocabulary. So for BERT model to train or fine tune, it needs to know where is my vocabulary. It should be hosted in some place, right? And the BERT vocabulary file will be within this workplace.BERT. And what we did, we just upload this BERT vocabulary to the remote repo, and BERT can just go ahead and find this vocabulary file and grab and use. So that's how it works behind the scene. And also we have this config file for BERT config, and it should also be living inside here. If you see the BERT config, you can see this is all the config function, how the BERT model trying to tune itself. As you can see, the hidden size, the number of hidden layers, which is the same exactly as to train the BERT-based model. And then we have this output directory, which is for our SageMaker to know once it's done the training, it probably will upload to S3. But within the local Docker, where should we put that model? So this is the directory. So if you do the Docker PS, I believe we can do it here now. So if we do the Docker PS, no, it's not here. If we do the Docker image as, yes, you can see we just have our image push, and that will be our Docker. And now let's come back to our script. So this is where model are going to live. It's called output directory. And we also need to let the model know where is the training data set, right? So what we're going to do for this session is we're going to use the SQL, Stanford Question and Answering version 1.1 to train our BERT file. And it's a huge file. And that's why we only train one epoch, even though we're using this 4 GPU. So this 4 GPU, how do we know that is for? We have specified actually here in this line as the MLP3 large. So if you just copy this AWS MLP3 8 large, so you will see how many GPU it has. So for example, as you can see, P3 8 large 8X has 4 GPUs, so it's 4 tests over 100, and that's 64 gigabytes of memory. So that's the instance we are going to use for the training. So now let's come back as for GPU, and it's 21 epochs because one epoch is probably take 5 minutes to train using 4 GPU. It can also train longer if you want. And the training batch size we specify here as 16 gigabytes. In case of it probably will be run out of memory. And we also have this max sequence length for the sequence. For the BERT model, for one input, the maximum sequence, maximum token count is 512. Also, we have all these other like docstrut, seeds, random seeds, learning rate, SIG2S3. The last one is very important. I see a question here that do we need to uncomment this? And the answer is no, because in our script, we specify SIG2S3. So basically this line over here, the S3 address, which is exactly here as the same as this line, because we specify this as a parameter in our training script. So the BERT training will just go inside to train using the script, and the script is already know that it will be trained save to S3 to this bucket. So that's why we do not need to uncomment this line, but this is a really great question. So that's the basic training hyperparameters. And now let's move to the next cell. So next cell, the first three lines is the same. We need to get the account, get the region, get the algorithm name. And what we're going to do is we're going to initiate or create our PyTorch model using the role. So the role is exactly what you have seen here, or it's a role that you're going to execute on your ACR repo. And then the next thing we're going to do is we have the training instance count, which we're going to use one instance from this P38X. And the entry point for the training will be the transformer script. And so that is basically used for inference. Well, exactly what training happened is back into the training script. So if you back to the BERT fine-tune KDD folder, and you will see this train. So this file. So if you open it, that's the training happens. So probably we'll see better here. So that's exactly the same file. So this training, as you can see, is specified where should it find the workspace, where the model should be, where's the input path, where's the output path. So they're all living in the train file. So SageMaker train, like that PyTorch model, we will just first come into that train and to execute everything. As you can see, the first thing if we're going to run will be the run squad py. So basically this file, as we specified out the parameter, the BERT model, output directory, etc., etc. And as you can see, we also specified the save to SageMaker directory as we specified in our hyperparameters here. So save to S3, which is exactly the same as like a save to S3 over here, which is the S3 bucket to save the model, etc. And so this is the training file. If you're really interested to know what is training behind the scene, what is executing there, to check this file, to see what is launching there, what is running there. So basically, first we'll run the squash download to download the original dataset for the BERT 1.1. You can also download the BERT 2.0, etc. if you want. So I believe I probably comment out this on my repo, but you can uncomment it if you want to use the 2.0. So basically 2.0 has some extra data which have no answer. It's like the question is not answerable based on the given data set. Yeah, I saw a question like that. Are all the training data downloads happening inside the Docker every time the torch model.fit is run? So yes, exactly. So exactly the training, it's exactly happening here. So here, as you can see, you initiate this model, you tell the SageMaker model, where to train, where's the image, where's the entry points, where's the framework, and the hyperparameters. And if you call the fit, it will just fit all the models. As you can see, my model has just finished running. It's just printing out a lot of things. So this probably I'll just download for the data. And now now we are start our distributed training over this 4 GPU. And here are all those parameters we are going to use to train. And as you can see, it also output one example as a demo. So while you're waiting for the training, you can also check to other script, which is the squad demo. If you open that, which I also opened here. So that is a little demo to show you how do we process the data set. So this is dive deep for someone who is not really familiar with the question answering. Basically, we concat the question and our context into one single large sequence, and we put them into BERT. And then the BERT will try to predict a label whether this should be a start token or end token. So that's how we are trying to pre-processing the squad example. As you can see, we build this squad example class, which is trying to process the raw input data. And we read the squad example. So what we're going to do is we just call this read squad example to read all those whole training files. So our training file in our case will be this 1.1 JSON. I saw a question. You can copy data to S3 exactly. You can definitely use the SageMaker.upload data to upload everything, your model, your data to S3's address. And so this is just a little demo to show you how do you parsing the squad raw data. How do you extract the features? As you can see, after we read the squad example, we print out the second example I create here. It's like the question is, what is in the front door of Notre Dame main building? And the document or the context will be tokenized in this format. As you can see, architecturally, the school has Catholic chapters, blah, 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 etc. So that is our context for our model to answer this question. And we can also print out the original answer, which is a Cooper statue of Christ. So this should be within, let's say, search the Cooper thing. As you can see, this is exactly here. And this is the BERT model will output the index for each of the tokens in the ideal case. So this is the raw document that we're going to read. As you can see, it kind of has some tokenizations mapped back to our vocabulary. And we also have some padding in the end to have the exact length of 512. We also mask it, like what the BERT usually do. And we also have this like 0 and 1 for question with 0 and 1 for the context. And that is an exactly similar thing as to what you're seeing here that has been output here, which is a couple of number, a couple of real tokens, which is kind of messy, but that is the real features for BERT. It's kind of the input IDs, input tokens, etc. So that's the perimeter train. As you can see, I just started my training. And it's just like train on different iterations within that one epoch. And if you just go down to the train, oh my God, it's pretty long. As you can see, once it's done the training, it will just uploading the model to the S3 bucket that we have been listed before. And if you want to really see your model, where is it living, you can just go to S3. So you search S3 here within the AWS console. And what you're going to do next is you will see, sorry, this is not, I shouldn't come to this one. This is my own repo. I'm sorry for that. Let's come back, search for S3. So S3 will bring you to your bucket and you click that and you will see your BERT model training. And that is your training that has been listed here. I believe my model is still trained. That's why I didn't say my model is like uploading there. But as you can see in my previous account, if I go to create my SageMaker, you will able to see, oh my God, that's a lot. Sorry about that. You're able to see this model tag on this bucket in my S3 buckets because in the script I just done the training. It will take like 1,500 seconds, so that's like 25 minutes. Sorry, a little bit long, but it works for us to wait. So at the meantime, we're waiting for the training. You can feel free to play with this question and answering demo, or I believe you can feel free to have a break while we are waiting. And please go ahead to ask any question if you have.
So Rachel, there's a question about the train file and when is it called in the main notebook? So I can maybe try to explain that. So essentially the estimator calls there's a script that there's an entry point for the script that it calls, and that in turn calls the main training. So I don't actually have it in front of me. Let me look real quick here. So in the entry point is the transform underscore script.py, and that then calls the main scripts. So always think about the estimator API being the entry point for everything. And then it makes a call to any type of scripts from that transform underscore.py. So hopefully that is clear there. Okay, so I think we're ready to maybe run through the rest of it. Rachel?
I think my script is still
run. Okay, so just want to take a poll on how's everybody running on the training. Did you all finish the training script or no? How's that going? So it does take a little bit of time. It takes about 20 minutes to train. So what you did is you're using about 4 GPUs to actually be able to do that. Still training? Okay, cool. So you would be able to tell what's the percentage of the training. So maybe you guys can. Well, I love how it's all still trainings. So if you think about it, we're actually doing distributed training. So let's see. So okay, cool. Yeah. So that's about right. So 1,500 seconds should be about right. If you think about it, what's really happening is that when you do the training, it has to download the data set. It has to download the container. So the actual training doesn't take that long. So it's really, the overhead. There's a little bit of overhead for downloading the data and preparing the containers. But at the same time, if you have something that would take you, say, 2 days to be able to train, or maybe a week to be able to train, so that overhead becomes negligible. But if you're doing something relatively small, So that does kind of add some overhead in terms of getting the container on it. So another best practice is to make sure your images are relatively small. So you don't want to have a really large image there. So I'll let folks kind of finish training. So maybe what we can do is to have people, essentially run through the rest of the cells. There's a deployment part of it, which essentially what you're doing is you're doing a estimator.deploy, and it's more or less the same story. You take that container, you have that container to be loaded onto a host instance, which Rachel is showing you now, and then that gets deployed and opens a REST endpoint for your client to be able to call. So instead of calling it locally, you're now doing that remotely. So what I like to do is to maybe have let's see. So yeah, it's not actually stuck. It's actually uploading the model. So for Han has a question, right? So it's actually uploading the model to S3 and then do the rest of the processing. So and what I want to point out is that this is a really, really large task. So what you're actually doing is fine-tuning a fairly large BERT model with lots of data, and if you were to do that on your CPU instance, it's going to take you, I don't know, the rest of the week. So it may look like, oh, it's taking a little bit of time, but at the same time, what you've accomplished here is actually a really large task that you wouldn't be able to do otherwise, like not on your laptop. So that's why you want to take advantage of distributed training. You want to take advantage of that infrastructure that's provisioned for you using SageMaker. So what I'd like to do is to maybe have Miro to come in and do the presentation on Nemo. And we'll just let people kind of finish running the rest of the notebook while he presents. So Miro?
Hey, can you hear me?
Yeah, we can hear you. Yeah.
Would you like to share your screen, Miro?
Yeah, give me just a moment here. Let me make sure I have.
Yeah, no worries. Yeah. So it looks like folks are actually, doing great on training. So some of you are done at 53%. Yeah, so just imagine that you're doing this in essentially, like less than 2 hours. If you were to, do this without the cloud, without these GPUs, without these tools, it'll probably take you maybe days or maybe even weeks to be able to do these type of operations. And in the good old days, you have to actually go provision. You have to go buy those GPUs somewhere first, right? So it's the cloud is much more convenient in that sense. So I'll let Miro set up.
Yep, I should be good. Let me see if I can.
Fantastic.
Share my screen here.
Yeah, you can just tell from my side.
Sounds good.
Yeah, so there was another question about the training container. So maybe Rachel, you can show them the training job inside the SageMaker console. So click on SageMaker console. You would be able to monitor. So for example, if you're disconnected, the training job is essentially submitted as like a batch. It is running in the background. You don't have to worry about it. So you can disconnect, you can go somewhere else. That job just continues to run even if you're disconnected from the, so maybe show them the, go ahead.
I have to rejoin the meeting. I'll be right back in order to
Okay,
share.
no problem, yeah.
Go ahead.
Yeah.
So,
so instead of showing me the log, can you show them not the cloud service, but show them the SageMaker menu under SageMaker and the
you want
actual
to share your screen, or you
sure,
can go ahead share your screen.
Okay, share. So so what I will do is, so I don't have a training job here right now, but if you were to go to SageMaker and go to SageMaker services. So for those of you who already have a training job running, so you want to go to notebook instances, and there's a training. you want to go to training jobs under training. And currently I don't have anything, but you should have a bunch of training jobs. You should have that training job running yourself. So let me actually clear the kernel. So Miro, let me know when you rejoined.
Yeah, I'm back. Let me try to see if I can share now.
Yeah.
You might have to make me a host again.
Yeah, so let me do that. So let's see. So where did Miro go? There you go. So I'll make you co-host again, and so you can present. Yeah. Okay. Cool. So I'll let you do that, and yeah, we have about 40 minutes left, so we'll get that presentation going.
Are you guys able to see my screen?
Yes.
Okay, great. So let me just really quickly walk through Nemo and then a very brief demo of
Can you
Nemo.
make the fonts a little bit bigger?
Yeah, sure.
Okay, cool.
So as we mentioned before, Nemo is open source and it helps you build conversational AI models. If you're interested in learning more about it, we have a website where you can learn about all the great benefits of it. We also have a GitHub repository where you can jump on and get more instructions for installing and all the different variations, all the supported models, et cetera, et cetera. Since Rachel and Wenming already covered a lot of the underlying concepts under all of the modern NLP developments, I'm gonna kind of breeze through that and just show you guys a example of sentiment analysis, essentially trying to determine whether a movie review from the IMDb dataset is positive or negative using Nemo. And one of the interesting things about this particular notebook, it comes from the Nemo repository, and you can actually find it if you were to clone it under the examples, NLP, and then text classification is the one that we're going to be running right now. And with this notebook, we're essentially cloning the Stanford sentiment dataset from the GLUE benchmark. If you guys are interested in checking this out more, the GLUE benchmark is a set of, it stands for General Language Understanding Evaluation, and there's many different tasks. These were kind of considered to be the gold standard in matching human performance as far as doing natural language understanding, but we've sort of, done quite well on these, and our models are still, I would argue, missing a lot of critical components. And so now there's a new version of these challenges, and we continue to make progress. But nonetheless, these are interesting tasks. The one that we're going to be working with is known as the Stanford Sentiment Tree Bank. And really that one is just all about being able to detect sentiment in movie reviews. So we've essentially downloaded and cloned this data set, and we have that here in our SageMaker repository. And with the rest of the notebook, we're just going to go ahead and kind of explore this data set a bit. Here you can see some examples of the movie reviews. So let's see. If you're curious about it, you're feel free to dig into the data set more. I'm going to kind of skip ahead a bit and jump forward to some of the visualization stuff. So Nemo is, just like Glue on NLP in that you can very easily load pre-trained models. And so here we're loading the BERT uncased pre-trained model, and we're going to be fine-tuning it. And let's see if I can just move down here a bit. and show you guys some of the more interesting things. One of the things that we're going to try to do here is set up this visualization tool. So we've created a set, you can almost think of it as a spectrum of words. In this case, they're like, 1 or 2 word sentences, and they're kind of going from positive to negative. And using the pre-trained BERT embedding, we've visualized, what the network thinks about each of these sentences along the spectrum of positive to negative meanings. And you can see that the network that has been pre-trained on the general corpus, like Google Books and Wikipedia, when you project its embeddings or its sort of thought vectors about the spectrum of words, it's kind of already linearly separating the positive and the negative words. So all of the negative words are the ones shown here in red, and all of the positive words are the ones shown in blue. And you can kind of imagine drawing a line of separation between them. So this is essentially BERT's thinking about positive and negative words before we did any sentiment fine tuning. So you can already see that the pre-training task is already quite good. And so next what we're going to do is essentially just run one epoch of fine tuning on this IMDb data set. And we're gonna, we'll go ahead and do that training. It took about 3 minutes to do. I'm skipping over this. You can, of course, very easily do multi-GPU training. And again, I'm skipping over this just for the purposes of being able to stay on track with the lab. And, with this fine tuning in place, we can do some interesting things, like we can write our own sentences. Like, so for example, here I've written a sentence: the SageMaker movie was an instant classic. You can write whatever kind of movie reviews you care about, and it will, spit out reviews. So for the one that we fictitiously wrote here, the SageMaker movie was an instant classic, it thinks that that's an overwhelmingly positive review, which is, not surprising, and so on and so forth. So you can write your own movie reviews and get them tested. But really the thing I wanted to show you was that once we've done this fine tuning now on the IMDb movie dataset, once we go through and do the visualization of the positive and negative sentiment spectrum of those same words / sentences, you can see that once we project them down into human visualizable space, they have been pushed to opposite corners of the spectrum. And so essentially what this is telling us is that fine tuning is doing a really powerful job of honing in on our specific task and changing the weights of the network such that the things that really allow it to do well are highlighted. So whereas these before were linearly separable, now they're sort of on opposite ends of the universe, if you will. And so I just really wanted to show you guys a quick few minute tutorial with Nemo. I think if you're interested, be happy to answer questions and also talk through any of the other really cool optimizations that are happening under the hood. But probably most importantly, welcome you to jump in on the NVIDIA Nemo repository, where you can find the latest and greatest things, like being able to train models that are too big and have to be split over the course over multiple GPUs, models for text to speech, ASR, et cetera, et cetera. So it's a really powerful framework. I really highly encourage you to check it out. And of course, being an NVIDIA product, it's very, very fast. So I'll pause there and see if there's any questions.
So one question, this wasn't in the original repo that we had for this session, right? Because I could not find the SM_ sentiment analysis.
That's right. So it actually lives in the NVIDIA Nemo repo under examples, and then under NLP, and then lastly under text classification. And that's the sentiment analysis with BERT notebook that I'm running.
Yeah, I want to make sure that people understand this is not part of the lab. This is something that it's a demo. It's essentially what Miro is showing you like another example of how this would work from end to end.
All right, great. I'll hand it back to you.
How's everybody doing on time? So were you able to finish the training? Good. Okay, great. I see. So I did see a few people saying that the uploading has some issues, and some other folks said the training job has failed. Okay, how do we get to the URL, the endpoint? Right. So let me try to address some of these. So if you're so when you do the training, so in my, let me share my screen real quick. Yeah, so at the end of my training, it would have uploaded, essentially uploaded everything to the repository. So it would have taken about, I don't know, the 1300 seconds. So if you had issues with your upload, it probably means you didn't set up your permission properly at some point. And unfortunately, I won't have time to debug them individually. So what I would suggest that you do is try to just follow me along for the rest of the lab, and I'll explain some of it. And what I will do is I will keep the lab kind of open for another hour after after 12, and you can so we won't be able to be on Zoom, but you can try to rerun the whole script. So by going to, so you don't run it now, but you can essentially do a restart and clear, and then do a restart run all. So that should potentially help you fix the problem. So you can try to run it one more time to see if it gets through. So what I want to do is to kind of finish the rest of the lab and help you to understand what it's actually doing. So after we did the training, what's happening is that we uploaded this zip file onto an S3 bucket. So you should be able to see that in your, let me, oops, yeah. So you should be able to see that in your S3 bucket. Unfortunately, I don't have that done quite right here. 1 second. And then once that has been uploaded to your S3 bucket, mine is still actually running here. 1 second. That's why you have too many windows open. You run into issues. Okay. Let me see if this is the right one. Okay, yeah, so, all right, so this is the training, right? So everyone got to this point where either, it has completed. And the next step is that you're gonna be deploying that out to the system. So what you need is an endpoint name. So you're gonna set up an endpoint name, and then you also have the tell it where the model is at. So by default, it will be using, essentially the default bucket that the system has created for you. So for the bucket, you have, you'll be able to find in your S3 menu. And then the next step is that you set up what is the actual frame that you're using, framework that you're using, and then you have to tell it to deploy on the type of instances which you desire, which is the ML G4DN, which is the T4 instance type that we're running. So we're using essentially one count, so that's probably good enough. If you want to do auto scaling and another, having multiple endpoints to be able to run it, you probably use additional endpoints to be able to load balance the whole thing. So the last piece will take you about 500 seconds to run. And then after you've done that, you are going to be calling the endpoint by using the BERT endpoint predict. So as you can see that you created this by running the deploy model, and then once you get the handle of that, you essentially run predict by calling the REST endpoint. So in this case, it took about 7 milliseconds to actually get an answer back from the model that you have actually deployed. So that's the rest of the lab. So what I would do is I'll pause and see if there are questions here. So maybe you can just unmute and just ask a question, or maybe Rachel, if you see any questions in the chat window, you can just tell me, and we can probably have a discussion.
So one question about the upload failed stuff is that,
yeah.
So imagine that my job took five days instead of 20 minutes. I don't want to rerun it. And
Yeah.
if I had set my permissions wrong or something like that, would I lose all my work?
No, not at all. So you can set up checkpoints where you can save the model every epoch or so. And then that will just be, saved to your S3 bucket. And the other thing you can do is to just start training from the model that was last saved. And yeah, I think that would be the best way for you to be able to resolve it, because it does save a model every epoch that you run. So the other thing I wanted to show you is the actual endpoint that we deployed, right? So this was deployed over here, and you can click on it and you'll be able to see where the model, it's actually, where is the URL, which you can invoke the model endpoint. You can also look at the invocation metrics among other things. So in this case, I probably invoked it twice just now. So yeah, so you can't really see it from the metrics yet. In the training services, so going back in the training services, look at the training job. So I had a few of these training jobs that failed and a few of them that succeeded. So let's actually dive a little deeper into the training. So you can look at the history of which the training. So it was preparing the instances, downloading the input data, the training image download finishes, and it took about, I don't know, 15, 20 minutes or so, maybe. So the input data took a little while to download. And then once the training actually finished, you'll upload the generated training model, and then the whole thing completes. So the training took 20 minutes, sorry. Yeah, it took 5 minutes, sorry. 5 minutes is where the training started and ended. And everything, all the other preparation took about 13 minutes plus 4. So that's how you look at it. And if, see where things actually broke, if you're, let's just say, your training actually is broken and didn't quite finish, what you want to do is to go to the metrics, view logs. Yeah, you would be able to go to the logs and see what the training actually did. So in this case, I can see that mine actually finished. So for those of you who actually ran into problems, so take a look at your log and maybe tell me what it actually did. So here's, so this is the log which I ran, right? So the training iteration, and it finished, let's see, so it finished 69% and 99%, and it pretty much was, starting to upload the models back up, and it, finished the training. So there's a lot of log files. So in order to debug these things, you kind of have to look at these scripts to see what went wrong. Any other questions? So let me see if I can find the chat window. Where's the chat window?
Yeah, so
there's
I
the chat
saw,
window. Yeah, okay.
yeah, go ahead. So I saw a question that about the REST endpoints monitoring. So I think Wemi is just showing us, like on the left-hand side, there's like a container inside, and you can monitor your endpoints performance there.
Yeah, so there's your, the inference points, right? So, and we have our endpoints, so you can go to the configuration of endpoints, but it would show that, I only have one running right now, but you can configure that. You can configure the endpoints. There's a lot of different options. As I said, you can essentially have like multi-AZ among other options. And you can give it all of the traffic or parts of the traffic by configuring the endpoint configuration. Yeah. So any other questions? Looks like my Windows is a little small here.
I have a question regarding how the endpoints are. So how are we charged for endpoint usage?
Yeah, that's a really good question. The endpoint basically is an EC2 instance that is running, right? So it's a container that is actually continuing to run. So you'll be charged for the time of the inference starts until that ends. It's almost like the same as training, but in this case, if the inference is running, then you're being charged. So it's not like Lambda where you only get you're only being charged for the amount of time that you're running. So there are people that would take their model and distill it and try to put it on Lambda to run. So that way you're only going to be charged for per inference. Does that make sense?
Yeah, it does. Thank you.
Yeah. So are these scripts available afterward? Yeah. So all of these are still in the GitHub, so you can just look at it. From the notebook, yeah. So deployment took 600 seconds. What it's actually doing again is, let's actually just look at it, okay? It will have to download the image from ECR registry. It would have to start all the web servers. So in this case, you're deploying a PyTorch model. The PyTorch model uses MMS, which is our multi-model server, and that has to start. And then after that, you have to set up all the load balancers and all the other stuff in front of it. It has to load up the data, load up the model, and be able to do the serving. That's why it takes 600 seconds, and majority of it is spinning up that instance and then trying to spin up this spin up the web server, as well as downloading the images. It does take a little bit of while. So so think about your EC2 instance to be started. Starting that EC2 instance, it takes maybe 3 minutes, and then downloading that image takes, I don't know, 3 more minutes, and then you have to start the model server, maybe another 2 to 3 minutes. So that adds up to about the 600 seconds that we're referring to. Does that make sense? Okay, cool. Any other questions? Let me just go into chat. I don't know why my chat window keeps disappearing here. If you use your own Docker image, there is, let's see, images that's pushed to ECR to deploy on SageMaker endpoint for inference. Does it still support the canary deployment and monitoring? Yes, it does. Yes, it does. So the monitoring, among other things, is just really something you can attach to a just using using the API to be able to call. So is the deployment Docker container different than the training one? Can it take? Can you talk a little bit about the web endpoint web API? So the deployment Docker container can be exactly the same as the training Docker image. The only difference is that you're really you're just really setting up directories for SageMaker. So as long as you have the right content in the right directories, you would be able to do both training and serving. So the documentation is all within SageMaker, and it does talk about like which directory does what. So another question: what's the best practice in logging API input and output that store them somewhere? So you can, for the API stuff, you can use CloudWatch. So CloudWatch will basically do all of that for you. And there's also Cloud Trails that essentially logs the API calls. Yeah, so this is a lot of there's a lot of different AWS APIs that you can call. So I think the other thing is that the log would always go into an S3 bucket, right? So another thing you can take a look at for drift data. I think there was an earlier question about data drift. So data drift could mean multiple different things. One way to think about it is that, let's just say your API was specifically designed for a group of shoppers. Let's say your demographic is maybe teenagers who are buying I don't know, buying specific movie posters, right? And then what happens is that suddenly your demographic of the user for your website suddenly changed. Let's just say there's maybe a high school reunion. Maybe 30, 40-year-olds started showing up on your website and buying old movie posters. So that so these are all different ways to think about your model is no longer actually serving serving or giving out the right recommendation. That's the way one way to think about it. The other thing is that let's just say due to seasonality, people might start buying different things. So that's also considered a drift. So you can the way you do this is that you can use more recent data to hit against your model. So that's how you detect the differences. So any other questions, or maybe I missed a few? So for those of you who's had this upload permission denied, so what I would suggest is that you can try to basically set the S3 bucket and just make sure all the S3 buckets have the right permissions.
So I will have a question about how to use a single endpoint with a number of models, or potentially a model ensemble. But I understand that this may actually take a while. So who would be the best person to talk to? Is it Rachel or yourself?
Yeah, so either one of us is fine. So there is something called MMS. So let's see. So let me look for the multi-model server. So this is the multi-model server. So that is essentially what you want to be able to serve multiple models. And the way it works is that you have essentially models in the directory, in the S3 directory, and you can add them to your model serving. So you can add, so in fact, yesterday there was someone that was adding about 400 models to their model server. So definitely look at our documentation, given that we don't have it. Also send me an email. I can talk about it in more details.
Okay, and so can I also use a model ensemble with this multi-model server?
You can, the way I would do it is to probably put a little bit of put maybe like a proxy in front of it. So that's one way of doing it, and the other way is to maybe change make modification in your script to be able to do that. So at the end of the day, you're exposing a you're essentially exposing a REST API. So however you want to serve that. So for our model serving for TensorFlow, I think we use GUnicorn and Falcon, I think, for the serving. And then for PyTorch and MXNet, we use MMS multi-model server. So it just depends on what your invocation script looks like.
Yeah. Okay.
Any other questions?
There would be more details in this, but thank you.
Yeah, there is. Yeah, definitely reach out to me.
Hey, Wenming.
Yeah, go ahead.
Yeah, thank you for the presentation. That was really good. Had a question. I'm not sure if you've answered it already. How do we get charged during inference using the endpoint? Yeah,
so that was asked earlier. So inference is when the machine is actually running. When the when these models are actually, so this model, I don't know, I think this one is a different one. Let me try to find. There you go. So here the model is actually running. So this endpoint is deployed and running. So as long as this is actually running, you'll be charged. So you can think of it as a just an EC2 instance. So it will just keep on running. So there is no easy way necessarily to host an endpoint that you only get charged per inference. And you can try to do this with Lambda, but Lambda only supports relatively small amount of memory, and you can only use, I think it's 3 GB of memory maximum. So that could potentially be difficult, and only supports CPU. So there are some folks that are looking into it, but we don't have a solution at the moment. So for SageMaker endpoint, as long as that endpoint is running, you're going to be charged.
So technically, it would be 24/7, like if I have an active endpoint.
That's correct, and you can always turn it off. And what some people do is that they have multiple endpoint. One is like a CPU instance, and they also have a GPU instance that they handle. They can you can do auto scaling through the inference. So you can just scale up and down, but the minimum charge is going to be whatever one machine that you have. Yeah, there's unfortunately no way around it. So.
Got it. Thank you.
Yeah. And unfortunately, I have a bunch of windows open here. I want to show you. So in here, I have. Let me see. So I think I have. Yeah, endpoints. There's a lot of different configurations you can actually do. So you can also create a endpoint configuration. You can add multiple models in here. So essentially there will be like a product variant. So you can add like 10 models if you want. So I have 3 here, so I can just add one, and I can add another one. I can add this guy, and I can add another one, and then I can just deploy all of them, right? And then yeah, so I mean this, and you can also enable some data capture of like what's the actual input that's coming in. So there's quite a bit you can do with various options.
And then if I want, like I have deployed multiple models and I want to use one of them depending on the input, then that is something that I will have to specify to the configuration.
Yeah, you have to. And that would essentially be the name of the model. right? I mean, you just call the name of the model, right? So all the name of these three models that I just looked at, they're all different.
Mhm.
Yeah, you just have to call a specific one. And you can also, like it's just the name of the variant you can edit and change the name of the variant, right? So you just call it, like my tree ensemble, my deep learning model, my
Mhm.
like SVM model. I mean, whatever you want. So
And
yeah,
last
go ahead.
question.
Yeah, go ahead.
So suppose I only receive X number of inputs during inference. So I would ideally want to save that inference in a kind of a key value store. And whenever I receive something on the endpoint, I predict using the lookup, right?
Yeah,
Is there a possibility to do something with SageMaker?
you can use something like the DynamoDB to be able to save that. I mean, for fast lookup, and you can also, start other things on your model server, right? So for example, I can even start a cache. I might even start it like a Elastic Cache. Elastic Cache is another, service that we run. So you can call Elastic Cache. So it's, up to you. Or if you are really, really, really minding the latency, you can start maybe a small instance inside your model, the actual model that you're running. So you can do a custom container, you can run a separate process in there that does caching, maybe using, I don't know what you would run, but you would probably run things like a SQLite or even, I don't know, maybe a small version of like a SQL variant or Mongo if you wanted to, even yeah, any type of key value pair type of databases that you might want to run.
Perfect. Thank
So
you.
yeah, and that's by the way, that's a problem that a lot of our customers actually see. So they don't want that REST endpoint call when you actually call out to cache, right? So I mean, that way you can essentially put more logic inside that inference endpoint by bringing your own container. That way you will save a few trips.
Got it.
Susan, I have a question about Spark jobs. I don't know if you mentioned that or not, but is it possible to deploy Spark jobs off SageMaker?
Yeah, so you can. There's multiple ways you can do it. You can call out to EMR, or you can also do this processing job. So there's this processing job which you can deploy a Spark cluster. So SageMaker has this thing called processing job. Let me just Google it for you. So SageMaker processing job Spark examples, and you'll be able to find that. Yeah.
Thanks.
Yeah, so just you use that, and also there's like a Spark kernel. You can do that as well.
Oh, great.
Yeah.
Yeah, look into it. Thank you.
Yeah, I think we're at the top of the hour, and I just want to thank everybody for attending this, and especially in this COVID time. Last year we were in Alaska, and this year we're all staying at home. And I just want to thank everybody for helping, and also thank my co-presenter here, both Rachel and Miro. And I have my email here, as if you still want that $75 AWS credit, just feel free to send me an email. And I want to thank everybody for staying long to until the end of the lab. It is 3 hours. I want to give you a round of applause for getting everything working. If you're still having issues, you can continue to work on the lab. I will shut it off at 1 p.m. And this is Pacific time. And I'll try to stay on here as much as possible, but I think this might actually be used for another session. So I'll just stay here for a while to answer questions. Feel free to unmute yourself and ask me a question if needed. Well, thank you all very much. So I'll just stick around, and if you want to chat or you have additional questions, we'll be here for a few more minutes. And then the lab setup, it will continue to run for about an hour or so, and then I'll shut it down. If you're still having permission issues, you might want to just rerun it through the lab. And in this case, you can just go in here and say clear out the kernel, and just essentially restart and run all. That would kind of run through the whole thing without you having to change anything.
Thank you for this great tutorial. If there is no other question at the moment, can I steal a couple of minutes of you and explain, if you could
Sure.
explain how this multi-model to a single endpoint would work, and then what would be the so how does that work in terms of like, is it sitting on an EC2 instance? Is it like I don't quite understand what is the backend here.
Yeah, so the backend. Am I on mute?
Sorry
here?
to interrupt.
Okay.
Just one question.
Yeah.
I joined late, so I don't know about this $75 credit. So what's the deal about it?
Yeah, so you just email me, and I just make it really easy. So just email wye@amazon.com, and I'll be very happy to send you one. It's just that our marketing folks were able to get that to us just in time. So yeah, so back to the other question. So you were saying the multi-model endpoint. Yeah, so the way it works is that we have this multi-model server, which allows you to swap models in and out. It will cache that locally for the models it hasn't like seen well, it hasn't seen before, and then it essentially just caches everything. As you make a call to the endpoint, it will just serve that for you. Yeah. And also, Miro put a blog link to that. Yeah.
Yeah, so I just wanted to add that the multi-model server, which is really great, unfortunately, it doesn't have support for GPUs. And so if you're doing a model ensemble with a large NLP model, you may want to essentially do what's like bring your own model for serving. And what you're doing there is just containerizing your workflow and then wrapping that with a Flask endpoint. And so as part of your script, you could potentially do multiple predict calls on multiple models if you're doing ensembling. And so the link I put there in the chat is an example of a minimal containerized plus Flask inference example for SageMaker. And you can pick GPUs or CPUs for that. So just food for thought in terms of how you want to do this. I think the multi-model is a really great one if it happens to fit your use case. But if it doesn't, then you could always just roll your own custom logic and wrap it in a minimal amount of serving code.
Okay, so that's interesting.
Thanks, Miro.
So now the models are small, so it wouldn't be an issue. But I am using like a model ensemble instead of a single model. So then maybe that Flask endpoint that you just mentioned, would that be the way to go?
So that gives you the ultimate amount of customization. Otherwise, if you're like I don't know whether you're going to be able to do a ensembling with a SageMaker estimator. I know that SageMaker has support for scikit-learn estimators, and there are scikit-learn ensembles, but it might be a stretch for natural language. If you're doing ensembling with natural language, your best bet might be to just containerize and write your own custom script and then wrap that into a serving REST API with like Flask or something. The blog I just linked to has a pretty good example of how to get you started.
Thanks, Miro. The other thing I want to clarify is that the reason that multi-model server supports only for CPU is because you're constantly swapping out these models in and out for that particular endpoint. And for CPUs, it's relatively easy to do. for GPUs, you kind of have to load that into the GPU and then load it out. So that becomes a bit harder. But in essence, these multi-model endpoint, if you give it a model variant, it should be like by default, just using SageMaker endpoint, you should be able to service multiple model variant. I'm not sure if you saw the screenshot that I showed you earlier. So you go into SageMaker, you essentially just pick the one that pick like 4 or 5 or maybe 100. You can add like hundreds of them, even by a script, and then you can just have them be called that way. Another way to do this is to provide multiple endpoints, right? So you can do multiple endpoints that allows people to kind of switch between the two. So Flask would potentially allow you to have 10 endpoints on the same node, however you want to do this. And so does SageMaker. SageMaker also does provide you with the A/B testing built in.
Got it. Thank you.
Yeah. All right. Anything else? Okay, we'll still be here for another 3 or 4 minutes. And then I wish everyone have a great conference.